Hello friends, welcome to the Point. In this session, let's discuss about the second part of the earth, that is interior of the earth. Let's start discussing about the interior of the earth. It is said that the earth's radius is 6,370 km, where no one can reach the center of the earth and they can make an observation or collect samples of the material. Under such circumstance, you may wonder how scientists tells us about the earth's interior and the type of material that exists at such a depth. It is all based on the interferences and estimates done by the scientists, and the part of the information it is obtained through direct observation and analysis of the materials. There are two types of sources where the scientists have gathered information regarding the interior structure of the earth. One is direct sources and the other is indirect sources. Direct sources. The most easily available solid earth material is surface rock. We get this from mining areas. Gold mines in South Africa, they are as deep as 3 to 4 kilometers, and going beyond this depth, it is not possible, and it is very hot at this depth. And beside mining, scientists they have also taken up a number of projects to penetrate deeper into the earth so that they could explore conditions in the crustal portions. All over the world, scientists are working on two major projects, Deep Ocean Drilling Project and Integrated Ocean Drilling Project. In this way, the scientists have gathered the information regarding the materials collected at different depths of the earth through the process of mining. Volcanic eruption. It is another source of direct information, and when the molten material, that is the magma, bursts out of the earth through the process of volcanic eruption, it is available for laboratory analysis, and it is difficult to ascertain the depth of the source of such magma. Indirect sources. Earthquake, it is one of the best example of indirect sources which gives the information regarding the interior of the earth. We know that through the mining activity, the density of the material increases with the depth. The other indirect sources are gravitation, magnetic field and seismic activity. The gravitation force is not same at different latitudes on the surface. It is different at different latitudes and longitudes. It is greater near the poles and it is less at the equator. And this is because of the distance from the center at the equator, which is being greater than at the poles. The reading of the gravity is different at different places, and this difference in reading it is called as gravity anomaly. Gravity anomalies, it gives us the information about the distribution of mass of the material in the crust of the earth. Magnetic surveys, they also provide information about the distribution of magnetic materials in the crustal portion, and therefore they provide information about the distribution of materials in this part. Earthquake waves. The study of seismic waves, it provides a complete picture of layered interior. An earthquake, in a simple word, is shaking of the earth. It is a natural event. It is caused due to the release of energy which generates waves, and it travels in all the directions. All natural earthquakes take place in the lithosphere. An instrument called seismograph, it records the wave reaching the surface of the earth. Earthquake waves are basically of two types, body waves and surface waves. Body waves are generated due to the release of energy at the focus and then move in all directions traveling throughout the body of the earth. Hence the name body waves. The body waves, they interact with the surface rocks and they generate new set of waves called surface waves. The velocity of the wave changes as they travel through material with different densities. The denser is a material, the higher is the velocity, and their direction also changes as they reflect or refract when coming across materials with different densities. Emergence of shadow zone. Earthquake waves, they get recorded in seismographs which is located at far off location, and they exist some specific areas where the waves are not reported, and such a zone is called shadow zone. The study of different events, it reveals that for each earthquake there exists an altogether different shadow zone. The given figure, it depicts the shadow zones of P waves and S waves. It was observed that the seismograph, which is located at any distance within 105 degree from the epicenter, recorded the arrival of both P waves and S waves. The seismograph, which is located 145 degree from the epicenter, record the arrival of P waves but not the S waves. Thus, a zone between 103 degree to 142 degree from the epicenter was identified as a shadow zone for both the types of waves. The entire zone beyond 103 degree, it does not receive S waves. The shadow zone of S wave is much larger than that of P waves. The shadow zone of P waves, it appears as a band around the earth between 103 degree to 142 degree, which is away from the epicenter. The shadow zone of S waves is not only larger in extent, but it is also little over 40% of the earth's surface. Types of earthquake. The most common ones are tectonic earthquake, and they are generated due to the sliding of rocks along a fault plane. The earthquakes that are produced by the sudden movement along the faults and plate boundaries are called as tectonic earthquake. Volcanic earthquakes, they are produced by the movement of magma beneath the volcanoes, and this type of earthquakes, they are confined to the areas of active volcanoes. Collapse and explosion earthquake. In the areas of intense mining activity, sometimes the roof of the underground mines, they collapse, which causes a minor tremors, and these are called as collapse earthquake. Ground shaking may also occur due to the explosion of chemical or nuclear devices, and such tremors, they are called as explosion earthquake. Measuring earthquake. The earthquake events, they are scaled either according to the magnitude or intensity of the shock. The magnitude scale is also known as Richter scale. The magnitude given by the Richter scale, it relates to the energy released during the quake. The magnitude is expressed in absolute numbers from 0 to 10. The intensity scale, it is named after Mercalli, an Italian seismologist. The intensity scale, it takes into account the visible damage caused by the event, and the range of the intensity scale is from 1 to 12. Effects of earthquakes. Ground shaking, differential ground settlement, land and mudslides, soil liquefaction, ground lurching, avalanches, floods from dams, fires, structural collapse, falling objects, and tsunamis. Tsunamis occur when the earthquake takes place under oceans. Structure of the earth. The crust. It is the outermost solid part of the earth, and it is brittle in nature. The thickness of the crust, it varies under the oceanic as well as continental areas. Oceanic crust is thinner when compared to continental crust. The mean thickness of oceanic crust is 5 km, and whereas that of continental crust is about 30 km. The continental crust is thicker in the areas of major mountain systems, and it is as much as 70 km thick in the Himalayan region. Mantle. The portion of the interior beyond the crust is called the mantle. This mantle, it extends from Moho's discontinuity to a depth of 2900 km. The upper portion of the mantle is called as asthenosphere. The word astheno means weak, and it is considered to be extending up to 400 km, and it is the main source of magma that finds its way to the surface during the volcanic eruptions. The crust and the uppermost part of the mantle are called lithosphere, and its thickness ranges from 10 to 200 km. Core. The earthquake velocities, it helped in understanding the existence of the core of the earth. The core mantle boundary, it is located at the depth of 2900 km, and the outer core is in liquid state while the inner core is in solid state. The density of the material at the mantle core boundary is around 5 grams per centimeter cube, and at the center of the earth at 6,300 km, the density value is around 13 gram per centimeter cube. The core is made up of very heavy material. Mostly it is constituted by nickel and iron. And this layer, it is sometimes referred as knife layer. Volcanoes. A volcano is a place where gases, ashes and or molten rock material, lava, it escapes to the ground. A volcano is called an active volcano if the materials mentioned are being released or it has been released out in the recent past. The layer below the solid crust is mantle and it has higher density than that of the crust. The mantle contains a weaker zone called asthenosphere, and it is from this that the molten rock materials find their way to the surface. The material in the upper mantle portion, they are called as magma. And once it starts moving towards the crust or it reaches the surface, and it is referred to as lava. Volcanoes are classified on the basis of nature of eruption and the form developed at the surface. Major types of volcanoes are as follows. Shield volcano. Barring the flow of basalt, the shield volcanoes are the largest of the volcanoes on the earth. The Hawaiian volcanoes are the best examples of shield volcanoes. These volcanoes, they are mostly made up of basalt and a type of lava that is very fluid when erupted, and for this reason these volcanoes, they are not steep and they became explosive if somehow water gets into the vent, and otherwise they are characterized by low explosivity. Cinder cone volcano. In this type of volcanoes, if the upcoming lava moves in the form of a fountain and throws out at the top of the vent, and it develops a cinder cone. Composite volcano. The volcanoes are characterized by the eruptions of cooler and more viscous lavas than basalt. These volcanoes, they often result in explosive eruptions. Along with the lava, large quantities of pyroclastic material and ashes find their way to the ground, and this material, it accumulates in the vicinity of the vent openings, which leads to the formation of layers and thus make mount appear as composite volcanoes. Mid-ocean ridge volcanoes. These volcanoes, they occur in the oceanic areas, and there is a system of mid-ocean ridges which is more than 70,000 km, and it stretches through all the ocean basins. The central portion of this ridge, it experiences frequent eruption. Volcanic landforms. Intrusive forms. The lava that is released during volcanic eruption, on cooling it develops into igneous rocks. The cooling may take place either on reaching the surface or while the lava is still in the crustal portion. Depending on the location of cooling of the lava, igneous rocks are classified as volcanic rocks and plutonic rocks. The lava which cools at the surface are called as volcanic rocks, and the lava which cools at the crust is called as plutonic rocks. The lava that cools within the crustal portion, it assumes different forms, and these forms are called as intrusive forms. Batholith. A large body of a magmatic material that cools in the deeper depth of the crust, it develops in the form of large domes, and they appear on the surface only after the denudation process to remove the overlying materials, and they cover large areas and assume depth that may be several kilometers, and these are granitic bodies. Batholiths are cooled portion of magma chambers. Laccoliths. These are large dome-shaped intrusive bodies with the level base and connected by a pipe-like conduit from the below. It resembles the surface volcanic dome of composite volcano. Only these are located at the deeper depth, and it can be regarded as the localized source of lava that finds its way to the surface. The Karnataka plateau is spotted with the domal hills of granite rocks, and most of this now exfoliated, and they are the examples of laccoliths or batholiths. That's all for the session. See you in the next session. Thank you.